Today we're going to talk about angle-side, triangular congruence, okay? So, remember last week when I had talked to you about, like, when we compared two triangles and we checked each congruent part, how many angles are there possible in a triangle? How many triangles? Three. Good, and how many sides are there in a triangle? Three, right? So, remember last week when we compared all 6 parts together and we made sure all 6 parts were exactly the same and we said they're congruent? Remember that whole thing? Okay, so today I'm going to talk to you to tell you that there's actually theorems or rules in okay, so what we're going to talk about today is this angle congruence theorem. So ASA, I want you to write this down above your title, angle side angle, okay? Meaning, let's say, we're not going to look at all 6 parts of the triangle, but let's say we could prove that a consecutive angle, a consecutive side, and a consecutive angle are the same in 2 triangles. Then we could say both the triangles are the same, but they have to be consecutively together. Does that make sense? So we couldn't use random angles and sides to use this particular theorem. So write that down so you know what ASA stands for. It's angle side angle theorem. Okay? And our objective for this particular lesson is to be able to analyze side and angle relationships between congruent triangles. All right. So here we go. I'm going to move on. Vocabulary, you don't have to write this down, but this is the theorem. And you need to know this for when you go to Integrated Math 2 next year. You'll be using this. So angle side angle triangle congruence theorem is if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So you'll be using this rule next year when we start doing proofs in Integrated Math 2, okay? Which is the idea of logic, right? When I say all all San Dimas students are awesome, Marianne is a San Dimas student. Therefore, everyone?
Marianne is awesome.
Marianne is awesome, right? Okay, so we could use logic. So this is one of the rules for logic, okay? But we're going to focus on this. Here we go. So numbers 1 and 2. Watch me do numbers 1 and 2. All right. So we got 2 triangles, triangle A, B, C, and triangle D, E, F. And then I'm noticing, hey, I want to figure out if any of the parts are congruent. So I'm going to still do what I did last week, okay? But I noticed some of these things are not complete. So first thing I notice is that I'm like, hey, look, these 2 angles are 61 degrees, right? So I could just put 2 arcs here, right? And when I look at these triangles, the second triangle was imaged over by being rotated. You all see that? Okay. So, and then I notice right here next to it, or adjacent to this angle is a side. It says 2.3 centimeters here. It also says 2.3 centimeters here, right? So I could put these 2 together, right? Now, what do I know about all the interior angles here of any triangle? How many degrees are all the interior angles? 180. 180, right? And so if I were to calculate this last angle here, angle EDF right here, okay? If I were to take out my calculator and calculate it, I would see that this is 45 degrees. Now that's kind of nice because isn't this one also 45 degrees? Yeah. So 45, these 2 angles are the same, so I'm going to use double arcs on this one. And then I'm like, hey, look at this. I got an angle that's the same. These 2 45-degree angles are the same. I got these 2 sides are the same. And I got another set of angles that are the same. Therefore, these are congruent. Okay, I could assume they're congruent by the angle side angle theorem. So then I would write the statement, triangle ABC is congruent to triangle DEF by the angle side angle theorem. Okay? Does that make sense, everyone? Okay, number 2, we got 2 triangles here. We got PQR and triangle STU. Okay? So, when I look at these, again, I want to find some similarities. So, do y'all see down here it says 38 degrees, and this is 38 degrees? Okay, so I'm going to put a single arc here on each of them, just so it helps me see them. And then I notice this adjacent side is also 1 inch, so both of these sides are both the same. So I'm going to put a single tick mark there, okay? So that's kind of nice. So I'm noticing the second triangle is also rotated slightly, right? So now I have angle U here, or I'm sorry, angle SUT, which is 67 degrees. Right here, y'all see that? I'm wondering if angle PRQ is also 67 degrees. Okay, PRQ. Is this 67 degrees right here? Do we know that?
No.
We don't know that yet. Okay, so let's calculate it. So I take my calculator out, and I know all my interior angles of triangles are 180 degrees. So I'm going to figure out on my calculator what's 180 minus 72 minus 38. Okay, so when I do that, I get that this angle here is 70 degrees. Okay, I got a question for you. Is 70 degrees the same thing as 67 degrees? No. Are these congruent then? No, they're not. So can I use a common dash here? Nope. So notice how we have a common angle, common side, but we do not have a common second angle. So these are not congruent. So then we would say not congruent, or we could write it out that triangle PQR is not congruent to triangle STU. Okay? That's numbers 1 and 2. Any questions on this? Okay, so today the first rule, and we're going to look at other rules too to figure out they're congruent, is the angle side angle rule. So what I'd like you to do right now, let's hear some math chatting. Ones in my groups, ones. All my ones in the house. You'll be a 1 today, okay? Because there's no one here. Carly, you're 1, okay, for today. Your ones are going to explain how we know the number 1, the triangles are congruent, and how number 2, we can't assume they're congruent. Okay? Ready, set, and go. What information do we know about number 3 that we could assume? Which 2 angles are congruent?
A and C.
A and C, right? So we could say that A and C are congruent. So I put a single mark there, okay? What other angles or what else do we know that's congruent?
E.
Well, E is the midpoint, so what does that tell you about other stuff? No, we can't assume that.
B and D are congruent.
Angle E is
Okay, so would you agree that E is the midpoint of this and this? You all see that?
Yeah.
So wouldn't you agree that this is congruent to that?
Yes.
Right? Does that make sense? When you have a midpoint, don't you bisect the line segment into 2 perfect lengths?
Yes.
Okay, cool. What other information can we assume is true? Yep.
Line BD is the midpoint also.
No, we can't assume that. That's false. We can't assume that yet.
You use a 90-degree angle.
Is it 90 degrees? Is that what it says?
No.
No, we don't know how many degrees it is.
Oh.
Yep, Charles. Someone else. Okay, Tommy, back to you.
If A
Put it on my desk.
if A and C are congruent, then that means B and D are also.
No, we don't know that yet. We're trying to prove, are these 2 triangles congruent? There's one more thing you're missing.
E, can that be congruent? To its E.
There's one more angle that we could assume is congruent. Yeah, Matthew.
Wait,
What were we going to say?
I was gonna say because they correspond.
Which ones correspond?
A and C and D.
Nope, not yet. What 2 angles can we... Huh?
Am I close?
Nope. Charles,
Angle E on both sides are congruent.
how do you know that?
Because that's the midpoint for AC.
Okay, so would you all agree with him? Would you agree that these 2 angles are congruent? You all see this?
Yes.
What kind of angles are these 2, by the way? Starts with a V. Take your hood off, please. Thank you. They're vertical angles, right? So I got a question now. Now that we have, do you all agree that this angle corresponds to this angle? You see how they're the same? A and C. And would you agree that this side is the same to this side? Do you all see that? And would you agree that this angle is congruent to this angle? So do we have an angle side angle? Can we prove it with angle side angle? Yep, so these are the same. We would say that by the angle side angle theorem, these are both the same. Does that make sense? Okay, cool. Let's keep going here. Let's do this one as a group. You're going to talk to your group and discuss, are these 2 the same, okay? Don't just assume because one side looks shorter than the other that they're not the same, okay? Ready, set, and go. Okay.
That's 90.
So everyone's working on explaining if these two are congruent. Are these congruent? Why or why not?
Yes.
Okay, why though? You haven't proven to me why. Ryan, give me a detail of why they're congruent.
So if you add up the 17 from the top triangle and you add that to the 73 from the bottom one, it'll add up to 90. 90, and then the is already running.
Oh, you're saying so this down here is 17 here?
Yeah.
Would you all agree?
Yes.
Okay.
Add that up.
Right, because if you add... Oh, how many degrees is this angle here, by the way?
90.
Right, so if you take 90 plus 73 plus 17, you get 180, right? Would you agree that this, then 17's, these two angles are the same, right?
Yes.
Okay, what else can you assume? You haven't proven it to me yet. What else can you assume? Matthew. Matthew's talking. I didn't hear him. Go, Matthew.
K, L, and J are
K, L, and what?
K, L, and J.
No, we can't assume that yet. Yep.
Line KL and line JL are congruent.
Line KL and line J. That's what he just said. Nope. Yep.
If angle MLJ is congruent to KLM, then that means this side, the JMK, is I don't know.
You had it going.
We don't know that yet. There's something obvious that's there.
That means JL is.
Okay, raise your hand and I'll call on you. Shh. I like how you're thinking, but you're making assumptions based upon that aren't you can't substantiate them yet until you could assume something else first. Christian.
There's a 90 degrees.
Okay, good. So you see this 90 degrees here? How many degrees is next to it?
90
How do you know that?
because the box.
No, you don't know they're congruent. How do you know they're congruent? There's a reason. Tell me.
Because the other angles inside of the triangle are added up to the same.
Matthew, how do you know they're congruent?
Because 17, or if you put a 73 right there, 73 plus 17 is 90. 70.
No, but we already know this is 90. How do you know this one here is 90? Yep.
Because of linear pair.
Good. Did y'all hear him? Isn't this a straight line right here? And how many degrees does a line add up to? 180. Aren't these a linear pair?
Yeah.
Good. So if this is 90, then this 90 plus 90 is equal to 180. Does that make sense, everyone? Awesome. Okay. We're almost there now. Ready? So would you agree that this is an angle? Would you agree that this is an angle? Where's my common side?
KL and JL.
No, a common side.
Oh, ML.
Isn't ML the same thing on this bottom triangle as ML is for the top triangle? So aren't these both congruent?
Yeah.
Y'all see that? So don't we have a common angle, side, angle for each of these? Angle, side, angle. Are these congruent? Yeah, now we could assume everything else is congruent, right? We could say JL is congruent and KL is congruent. After we assume angle, side, angle. Does that make sense? Okay, cool. And that is it. So that concludes the lesson for today.